All right, good afternoon, everybody. We're going to go ahead into section 2 of this is our second unit of reaction types or chemical reactions. Our learning goal that we're going to be focusing on here is going to be 3.04. Looking at the fact that you'll be able to, by the end of this, you should be able to use visual diagrams to explain and display relationships between particle concentration, and molarity. Now, particle concentration is another way of saying molarity, but we're going to talk a little bit more in depth about what are the units that we're going to use to explain and to express molarity or concentration. So now, molarity itself is looking at the number of moles per volume of a solution in liters. So if I have that thought in mind, the thing that I need to remember is this formula given to me right here. Molarity equals moles of my solute, so moles of whatever substance it is, dissolved in however much of the solution. So we always want to make sure that it is in liters. I have to make sure that it's marked on there. Whenever we're doing molarity, we always have to convert it back to liters. Keep that in mind. So if you have a volume that's given to you in milliliters or parts per million, well, we'll talk about parts per million later. But if you have something given to you in milliliters, all you're going to do is divide it by 1,000, or the same as moving the decimal point 3 places to the left, and you'll be perfectly fine. Now, how does this work in terms of concentration? Now, if I have a 0.25 molar solution of calcium chloride, once I put this in solution, they're actually going to break apart. I have my calcium ions and I have my 2-chlorine. So for every 1 calcium chloride molecule or formula unit, I get 1 calcium, but I get 2 chlorine. That means I have twice the concentration of my chlorine ions, and that's what you see given to you right here. Notice that I have a 0.5 molar concentration of my chloride ions, whereas I only have a 0.25 molar concentration of my calcium ions. This is going to be very, very careful, and there are going to be some notes that you need to make sure that you pay attention to. Now that I have this sort of idea, I want to go through and think through the process of what you need to look at when you're trying to find the concentration of specific ions now in solution. Now, before we talk just briefly about the concentration of an overall substance, but we can break it down into what will the concentration of the ions themselves be. So let's take a look at the process. Here's where we're going. We need to find, or sorry, where are we going in this case? Sorry, typo. We need to find the solution that contains the greatest number of moles of ions. What do we need to do in order to get there? These are the steps we're going to follow. Draw a molecular level picture showing each solution and think about the relative numbers of ions. So if you're seeing that it is, say, 0.25 like we looked at in the situation, 0.25 molar solution to 1 liter, in my mind I would think, okay, so about a quarter of it should be filled with this particular ion. We want to pay very close attention to those types of things. How many moles of each ion are in solution is going to help us to get a better picture of that idea. Now, pay attention to this, and I made sure to put this on there at the top. Pay attention. Now, the solution with the greatest number of ions is not always necessarily the one in which the volume of the solution is the largest, or the formula unit has the greatest number of ions. What do I mean? I could have one with a very, very high concentration, but a low volume of liquid to displace it, or low number of liters in this case. If that's the case, then it would show that I would actually have a higher concentration. So you want to pay attention and actually go through and figure out the number of moles to do so. Now, if I have some type of solution, and of course with all of these we're going to have practice, so don't worry. If I have some type of solution, and we'll call it usually a stock solution, what I'm going to do is if I need to make a smaller or a lower concentration, what I'll do is I'll just add water. But I have to know how much water I'm going to add. Now, dilution, as with anything else, if I was diluting water, if I was diluting Kool-Aid, if I was diluting whatever, I'm just going to add water to adjust the molarity to get it to where I want it so that I have the right concentration. So when diluting water, it doesn't alter the number of moles. I'm just adding water. I don't change the number of moles of the substance. So that part will stay the same, but what will again change is just the molarity. How we're going to deal with that is we have moles of the solute before dilution equal moles of solute after dilution. Or, as you see here at the bottom of the screen, molarity 1 times volume 1, so whatever the molarity and volume were, equals molarity 2 after we've done the dilution and times volume 2. Now, if I have any of these pieces, I can solve for the one that's missing. So if I'm given, say, my M1 V1 and my V2, I can solve to find out what the molarity is. We're going to do some examples, and I'll post some examples of how actually to go about doing these. It's not really much of a problem. It's basic algebra. I think most of you will be okay with doing so. But we're going to use this also when we get into the next section just a little bit, so I want you to keep that in mind. Now, this is where we're going to end section 2. Take a moment, go over your notes, revise them. If you have questions, write them down. I know you're thinking, I'm going to have them, I'm going to remember them when I get to class. But 9 times out of 10, that does not happen. So make sure you write them down and bring them to me so I'll be able to answer them and get you set out on the right way. Have a great evening. I look forward to seeing you in class. Have a great evening.